Okay. Hello, it's me again.
Can you share the screen, please?
Can you still hear us?
Apparently, oh, you share the screen, I think.
Apparently, we don't share the screen anymore. Start sharing. Sorry about that. That's gone away. Okay. Now I'll talk a little bit about the farm that we have here at Jefferson Lab and how to submit jobs to it. If you're running on your own cluster, you're on your own. I can only help you here. This is an older picture of the farm with a nice panel. So the outline is basically in this plot here. So you're the user, and you have to interact with the batch farm, and then also you have to get somehow your data off of tape and read it in. But luckily there is a system which we call Swift that handles everything for you. So you basically only have to interact with Swift, and this will take care of both the tape library and then also all there are actually two schedulers at the moment working the batch farm here. There's an older system called PBS, which will be slowly replaced by Slurm. And at the moment, the farm is somehow split into two systems. Part of it is governed by PBS and the other one by Slurm, which sometimes makes things more complicated, but not for the user because we have Swift. Okay. So a word on Swift. Swift is an abbreviation, but it's like Jefferson Lab Scientific Workflow Indefatigable Factotum. But you don't have to remember this. The only thing you have to remember is that this will work for you, so you don't have to expend unnecessary effort. So it efficiently handles the I/O with the tape library. It also helps you with bookkeeping, classification of errors, resubmission if some of your jobs failed. Can also handle job dependencies, so you can submit a job that depends on the successful finishing of another job and a completion of another job. You can do things like this. And there's some documentation on the SciComm website and also here in this document that the author Chris gave at a collaboration meeting a few years back. Now Chris is still at the lab and he's working on a Swift 2 system that actually works similar but submits to offsite computing resources like NERSC, Pittsburgh supercomputing, or maybe even the OST. But this is work in progress, and at the moment the standard user can use Swift only to run jobs here at the farm. Useful commands. The first thing, Swift help, that gives you all the commands that they are. Or even deeper, if you don't understand another command, you can just Swift the command, like Swift list, and then help afterwards. It will always print the usage instructions of all these different commands. Just a few that are important. Swift list displays all your workflows and shows what problems there were and how many jobs are still running and these things. You start by creating a workflow. So Swift creates a workflow, creates a new workflow, which at the beginning is empty, and then you have to add jobs to this workflow. This is actually quite complicated because it requires many commands, like how many CPU, how many cores you want in your job, how much RAM, what is the input file, where to put the output file, where to put the log. So this should be usually done with a script, and I will come to this in a minute. So we will provide scripts for this. And then once you have added jobs to the workflow, you can again look at it with Swift list, but it's not running yet. So you have to say Swift run and then the workflow. And once you see that there are some problem jobs that have a bunch of different problems, you can always try to resubmit them with this with this command. Now, what are the possible problems? Swift user non-zero is the most common. It's your fault. Your program crashed. That's what it means. So your program didn't exit with a user code 0, which means it didn't exit successfully. And so you probably have to check what's going on in your code. The other things, there is some augur failed, Swift error, augur unknown. These occasionally happen. Usually you just retry the job and then they work. I never really figured out what's going on there. And then there are some of the error messages that are related to the resources you specified. Like timeout usually means that you asked for 2 hours, but your job didn't make it in 2 hours and got kicked off the farm because you said it would only take 2 hours. So, but you can resubmit it actually with a modified resource description, or you just kill it and resubmit it again with 4 hours or 8 hours. And this is the same for RAM. So the R here stands for RAM. If it requires more memory than you asked for. And then at the end, you can cancel the workflow, or if you want to get rid of it altogether, if you don't even want to keep track of the workflow you had, you can delete it, and then it's gone forever. Okay. So one thing that helps, in addition to the command line, is the web page, Cycomp web page. It's linked here. It doesn't look like this anymore. There are much more nodes actually available, but it sort of looks like this. You have every machine, every node has a column here, and the height of the column says how many cores it has, even though it counts also hyperthreads. So these machines here, they have 80 slots open, even though they have only 40 processors. But they accept 80 individual jobs. You only ask for one core. But then you have others that have less. And if it's blue, it's occupied, and if it's green, it's empty. And if it's purple, it's occupied, but not by CPU, but just by memory, which is bad. So never ask for all the memory of a node, even if you don't need it, because then you would block other people from working. So there's all of this useful information on the webpage. The batch jobs and also Swift. You can look at your workflows here on the Swift. You can look what the file system is doing. Look at the tape library or the cache. All sorts of usage statistics that you might remember from the talks I usually give at the collaboration meeting, and they also come from here. Now, on the right top side, there's a little box where you can put in your username, and this will highlight information for your username. So this is my username, and then you get this line, which is outlined here, and you see at this point in time, I had one pending job, and that was it. So I just had one pending job. Usually, so it starts here, dependency means it waits on tape, then it's pending, then it's staging in and running, and then it's done. And if you click on not outstanding jobs, but recent job, you will see all the jobs that already finished with information on. If they finished correctly, then they have a 0, or if they had a problem, then they will have another error code. So you can log into this webpage without any password. It's just for highlighting. Then coming to the scripts. So we have the scripts in the SVN repository. Here, one for running hdroot, and one for running the deselector, which is called root analysis, and the other one is called launch. It's really an easy-to-use framework, but it's also used for the official production and analysis launches. So it is under constant development, is actively supported. For example, when Slurm came in, it required some modifications. This was done, so if you just check it out from the SVN and keep it up to date, it should always work. And yeah, it can not only be used for reconstruction and analysis, but even for your deselector, the same script. the system consists of 3 different files. One is called launch.py. It's a Python program that actually submits the jobs to your workflow. There's a bash script that runs on the farm node and handles I/O and these things. And then there's a config file. And you as a user actually have to only look at the config file. Everything else is standard. So you edit the config file, and then you start or you add jobs to the workflow by this launch.py with the config file, and then you have a run range from this run to this run. Everything pretty simple. Okay, how does a config file look? This is an example config file that you can also find in this folder. There's some information here, like the project just for accounting, GlueX, track, analysis, can also be reconstruction or simulation, and which operating system. Our standard is CentOS 7. And then you tell the job what the resources are required. So number of cores in this example 12, 10 gigs of RAM, 10 gigs of hard drive disk, and a time limit of 4 hours. But it can be anything, so you can just put something here. And then some information related to your analysis, so which run period, which version, even though these 2 things are only used in this line. So you can also call the workflow my workflow, and it will have just this. These are just replacements. And then some things you have to put in, like an environment file for your environment. Here I actually have still the environment from last year, but you can put in your environment file here. The script file is the script file that I just mentioned, and you can the jobs in your run range are selected according to this RCDP query. So you can use this. This is standard as well. You have a Jana config file if you run Jana, and yeah, this is only if you save the files to tape. You have an incoming directory and then an output directory, large, which is for the files, and small, which is just for the log files. Okay, so example, you set up the workflow, you register jobs. You can also not only register jobs in a run range, but actually only, in addition, you can use the files only between a certain range. So this would, for example, only use the files that are 000, 001, 002, and up till 4. Not the entire run. A run has up to 200 files. So this was just a small example. Yeah, the only first 5 files in this example. So you set up this workflow, you add the jobs, you run the workflow, and then you can check what's going on. You either do Swift list, you check on the web page, or the output folder. Pretty easy. In this example, I just recommend you, if you really use the config file here, copy it to your own place and probably change the out directory, because otherwise everybody will just write to the same space. And that's not good. Okay, and the config file to running a deselector actually looks exactly the same. So you have the familiar things here, like the resources, the name. The only thing which is different is that it has a root script here, and this is actually the run deselector that comes with the system. You have a tree name, which should be the tree that you're analyzing in the file, and then you have a name of your deselector. And that's the only difference. And then you have input and output similar to the other one. And again, you run it like this. You create a workflow, you register the jobs, you run it, and then you check what's happening. Pretty easy. The end. If there are any questions, yeah, enjoy Slurm, which is the system that handles the job at the moment on the JDEC farm. Just ask on the Google group, or I don't know. Here. Yes?
I just have 2 comments. One of the auger failed errors if you request more than 10 gigabytes of RAM per core. It will not let you do that because the nodes are like memory limited. So if for whatever reason you have some massive job that requires more than 10 gigs and is also single threaded, you have to ask for 2 because they will not let you submit. And the other one that is very common for people using Swift, maybe for the first time, if your jobs go to Slurm, Slurm has the added requirement that the log directory must exist before the job starts. So if you get a block of your jobs that all say Augur failed, you might just want to check to make sure you have that log directory set up, and then you try.
Right.
Is that part of our standard script to write create the log directory?
The second thing that he mentioned, yes. So I modified the scripts here so that they make sure that your log directory exists before they submit the job. But of course, you have to keep your software up to date to have the latest features. This came in fairly recently, and we still get emails sometimes that users don't have it. And the second thing, it's true, but it's really hard to find out the exact details of what are the limits on the farm. So yeah, but it's a thing that you in general shouldn't do. Request 1 core and then 20 gigs of RAM. But it's really hard to find out exactly what is allowed and what not.
I had, this was a while ago, I actually had the problem where my job would, and I requested 1 core and 10 gigs of RAM, and it wouldn't let it, and then eventually I think he was stepped in and said, oh yeah, there's a hard cap that we place.
Right.
If you really need it, then it's a 2.
Yeah.
Well, yeah, maybe one thing to point out is that, soon, they're putting Augur to sleep, so, everything will just be Slurm, so you won't have a choice.
Technical question. So when you specify, let's say, 8 cores, do you have then in HT root minus n threads 8?
If you run the deselector, then yes.
Okay.
It will run automatically on in multi-threaded mode in proof with the number of cores. If you run the Haldi recon, you have to put it in your config file, the number of cores.
Yeah, but the reason I'm asking this question is the following. So if you request 8 cores, would you use minus n thread 8?
Yes. Yes.
Okay.
So what they call here cores is actually it can be a hyperthread. It doesn't have to be a physical core.
But the reason I'm asking this question is that because even if you run HT root with 1 thread, you still have about 4 threads that run. Because when you read the data, you have more than 1 thread. So what happened? Is that a problem to some degree that you slow down the machine? Because you request for 1 thread, 1 core, which is 1 thread, you run that, but actually you will have certainly more than 1 thread.
But those aren't active threads. They're not using 100% of a hyperthread, and they're just reading the data,
They're
right?
just reading data from the file and buffering it. But that's a technical question. I have no clue.
Yeah, I don't have experience with it. Usually when we run a Haldi recon, it's always many threads, always 12 or 16 threads. Doesn't make sense to run with a single thread because it takes a very long time.
I just want to point out that even if you request only 1 thread, you still have more than 1.
Yes?
I have a question about the Jana config file parameter there, and how that is different from the HD root config file and or a Haldi recon config file.
This is the Jana config file is exactly the config file that you use for Jana or Haldi root.
So all those 3 things I described are one and the same?
Yes.
Good.
Random question. Any chance that it can migrate from SB into Git, like HD?
That is probably should be done, and then the next year we have something new to report.
Okay. Thanks.
You want to start with this?
No, you can do it.
Thomas, now you have 25 minutes.
Okay.
Right.